So without further delay, here's your Delphi instructor.
Hello, and thank you so much for joining us for this live training program on OBD II Mode 6 data, helping you reduce your emissions and OBD II related comebacks with Mode 6. Now, what we're going to get into this evening are a few simple things and a few more complex things. We're going to talk about some of the general terminology right off the bat, TIDs, CIDs, MIDs, what they mean, and what do they tell you, and why is sometimes Mode 6 data so difficult to interpret, and what to do when the data looks strange on your scan tool. We're going to also look at where you find Mode 6, which scan tools have it, which ones don't typically, and a little bit of pathing examples of how to locate it on your scanner, and then also emphasize some differences between global OBD2 or generic OBD2 Mode 6 versus enhanced powertrain Mode 6. So let's get started talking about monitors, which is the heart of what Mode 6 is. Mode 6 is simply a deeper look into what was going on, the mechanics, if you will, of an OBD2 monitor. A monitor is simply a test that determines if a particular system within OBD2, we'll say catalytic converter or the evaporative emission system, is not working to a point where the emissions, either out the tailpipe or out in the air with the evaporative emissions, are going to be 1.5 times greater than what the federal test procedure allows for. And typically that will throw a check engine light or a MIL, malfunction indicator lamp, but not all cases. Mode 6 will tell you how close you are in many cases on the non-continuous monitors. And there's two types, continuous and non-continuous, as we review a little bit of OBD2. But the non-continuous ones are what we're focusing on. That's what Mode 6 is about. When the monitor runs, we store some information when it ran last about what was going on, the details of that monitor. So monitors, it's important when you look at a scanner, and here it looks like an EASE PC-based scan tool that is showing us the monitor status, whatever kind of scanner you've got, monitor readiness or monitor OBD2 monitor status. You need to see everything seen complete. Now the comprehensive components will always say complete. It's those non-continuous components. Those are the ones that will pop up and say complete one by one as you go through an entire OBD2 drive cycle. That's what we want to see, everything seen complete before we can trust the Mode 6 data. Now, let's go ahead and talk about the continuous monitors, which are not Mode 6 typically. And those would be the fuel control, misfires, and I'm going to put some question marks up there because I said the word typically. In the world of OBD2 and specifically Mode 6, a lot of information has lots of variables, which can lead to some frustration, but it's also can lead to a little bit of rhythm and getting used to variations and getting the groove so that you can fix cars efficiently. Now, comprehensive components, whether it be engine controls or transmission controls, consist of solenoid outputs, sensors, things like that. Those monitors always run. They'll always say complete because we're always checking to see if that mass airflow is putting out a signal or if that throttle position sensor is not below half a volt or let's say above 4.5 volts. It's somewhere in that working range. If it falls out of that range, it's an open or a short, we should set a code because the monitor for that runs all the time. That's comprehensive component monitors. Now, in true non-continuous monitors on our next slide right here, we see evap systems are in there, and we know those are non-continuous because you've been frustrated, I'm sure, as a tech working on an evap code that you can't get to seem to run the monitor after you think you fixed it or you think you found the leak or whatever because it's very non-continuous. Once per drive cycle, certain temperatures got to be met. Might have to have between, let's say, 15 and 85% fuel level for the leak test to work. All that kind of stuff can lead to frustration. But if we can get it to run the monitor at least once, even though the light may not come on, maybe even we don't have a pending code, we don't even come right up to the fail point, Mode 6 will tell us how close we got to that edge. Catalytic converter efficiency is another one of those good ones. The 420s and the 430 codes that we struggle with, Mode 6 can come in and help you there, reduce the comebacks by seeing once a monitor ran, how close it's going to be to failing. O2 sensors, while we're on that topic, also can be non-continuous monitors as well as the heaters, of course. And catalytic converters that are heated. Heated catalyst, very, very rare. Some of the high-end Euros, but most of the time you see a cat underneath the car. There's no fuel line going down to it. There's no electrical grid trying to heat it up. So most of the time you will see that say not applicable or unused or something to that effect. Thermostats, however, 2002 and up, we don't have a wire going on the thermostat, but we're looking at the temperature changes, determining if the engine's got a good warm up and cool down rate as if the thermostat's working good. But keep in mind, simple stuff can make some of these high-tech monitors fail, such as low coolant level can make a a thermostat monitor fail. EGR is a good one, EGR flow using mode 6, variable valve timing. Getting those cam phasers stuck because of infrequent oil changes, 2005 and up. AC systems was never used. It will always say not supported or not applicable because R12 never seen the light of day with OBD II. R12 was pretty much done in 93. OBD II pretty much started 94 and then came on full strength in 96. PCV valves, however, we can see if that's working, not exactly looking at the valve itself, but looking at some other things. 2004 and up, plus your air pumps and misfires. Question mark again. The reason I put the question marks up there, if you're working on some vehicles, misfire monitors will not be looked at in mode 6. It won't be there, you won't see it. In other vehicles, you will see it. In fact, if you're watching this program and you've ever used mode 6, you probably used it on a Ford post OBD II, but pre-CAN, because those were frustrations waiting for technicians who didn't have the factory Ford IDS scan tool. There's where mode 6 really came out of the darkness of an engineering mode written by engineers for other engineers, but was kind of hidden in our scan tool, and technicians discovered it and said, you know what, this is in hexadecimal, mumbo jumbo, but I'm going to try to figure out how this can help me, and they found it was excellent on Ford misfires. So let's get started right here. Speaking of Ford, of the which scanners do this and which scanners do that. Now the IDS is one of the early ones that came out as a factory scanner, factory true dealer scan tool that did mode 6. And because it's PC based with a multicolored screen, you can see in yellow, green, and red a little bit of a color indicator how close we came to failing a test. Of course, green being you pass with flying colors. Yellow means caution, we're really up against that limit specification-wise, and red means you failed. You failed that particular test. On the left, we have a description of the general area, sometimes called a test ID or TID, and then we have the specific component that we're looking at over here on the right, and then the values are slid in there. Now, what other scanners do mode 6? Well, obviously, you're seeing the IDS does, but also Toyota TechStream, which is a PC-based factory scanner that not only can be put on the Panasonic Toughbook with a special VCI, you can use your own VCI, your J2534 Universal Reprogrammer, whichever brand you have. Toyota will work well with all of them being the pass-through between the Toyota, Lexus, or Scion vehicle and your laptop. Not only factory scanning, but it does a really nice job on mode 6, complete with a color-coded bar that shows you visually at a real quick view where the parameter fell when that monitor ran, and we did that snapshot in history of what was going on with the mechanics, the details of the monitor, all the various tests that have to run for that monitor to say, I ran that test on some particular system. Chrysler DRB3, DRB2, on the other hand, never had mode 6, and GM Tech 2 did not either, so the majority of the older factory scanners that you're more used to, if you're a tech not working on the latest new cars, did not have mode 6. All the aftermarket tools, though, they all have mode 6, as well as most of your code readers. The code readers won't put it in really easy to use format, but they have mode 6. So this is something primarily the aftermarket has had, and the factory tools have recently started adapting. Let's go ahead and give you a little pathing through this aftermarket, I'll call it near factory level scan tool. We're seeing a little screen capture, actually a little photograph of where you find mode 6. It's going to vary from scanner to scanner. You have to find out how it does it, but it's somewhere something like this. You go into preferably OEM enhanced powertrain. Build the vehicle up as if you're going to see all those 100 or 200 or 300 data PIDs. And when you build the vehicle up in enhanced powertrain, find the general main menu. That's typically where you'll start. And then look for something like special test or non-continuous monitors, it might say. In the case here, we see special test. We click on it, hit enter, and then we see non-continuous test, in parentheses, mode 6. That's what we're after. We'll also see here drive cycle, output controls, and so forth. So it's going to be laid out differently in everybody's scanner. And after we click on mode 6, then we're going to see this engineering, which means nothing to us. But we see 4 of these items failed. The TID, which we'll explain what that means in a minute, and the 2A and the CID 00 and so forth. All 4 of those failed. And then if we scroll on down, we see a whole bunch more that passed, actually. Being kind of a monochrome screen, we're not going to see green, pass with flying colors, yellow, almost failed, and red failed, but we do see pass and fail. But what can I do beyond here? I hit enter once again, and that's going to give me the definition of what that particular TID test ID was, and it has to do with a type A, that's a pretty severe misfire, and it doesn't say which cylinder, but actually that will come up later here. But it does say 15,360 was our maximum specification. We're at 16,506, so we're well above that max level. Of course, there's no minimum limit because you can never have too few of misfires. And it does say it's failed, and the ECU, the electronic control unit, in this case is 10, $10 I should say, and that would be the PCM in this case. So that's its ID on the data bus. So that's how you navigate on this particular scanner. I'm going to show you on a PC scanner how you navigate with our Delphi unit. So practice with your own and see how you get around. So let's go ahead and do that now. We're going to do a little practice with mode 6 on a classic case. If you've ever done mode 6, I know you've done it on a Ford pre-CAN post-OBD II misfire, especially those intermittents where you're really not sure what cylinder is misfiring. You don't have the Ford IDS, which makes that work easy, but you do have an aftermarket scanner with mode 6. So let's get started and do this case study. Working on a 2001 Lincoln Town Car with a misfire complaint. Customer says it runs rough and that check engine light comes on when it does run rough. We asked them if it was flashing. They said no. We were able to take a quick drive and see the problem ourselves. Feel it, the light was on, pull back up to the shop, set the car up, and guess what? We found no codes. As a matter of fact, we went into the enhanced powertrain, and when we went into enhanced powertrain and we did the key on and the engine off and so forth, accidentally set one code in the P1464, meaning we had the AC on when we were doing the key on engine off test. But there was no other codes besides that. We went into generic as well, and there were no trouble codes in the powertrain there either. And let's look at emissions-related codes here. Mode 3, no codes. Now, how can this happen? Well, you run into things like this periodically. You know as well as I do, the MIL, although it technically stands for Malfunction Indicator Light, can also stand for Misery Indicator Light in some tough drivability problems. So, what we're going to do is try to turn this into a money indicator light for you, give you some mode 6 tips on this pre-CAN bus Lincoln. Let's go ahead and go into powertrain, and we'll go into mode 6 from the enhanced side of powertrain, which is always preferable because those parameters will be spelled out, unlike when you go into mode 6 from the generic side of your tool. So we're in the enhanced side of powertrain. We click on mode 6. So as the car is talking to my scan tool and everything, going right into my computer, my laptop, I'm going to tell you what each of the columns mean and what some of the terminology means. The dollar signs, that's just an indication that we have a hexadecimal numbering system as opposed to a base 10 like most people use. And as we talk about this first column, test ID, that's the general area of OBD II mode 6, like catalytic converter efficiency, evap monitor, and so forth. The second column being more specifically drilling down to what aspect of the evap is failing or what aspect of the cat efficiency are we looking at here. And then of course the result is pass or fail. All the fails will come to the top on any scan tool. So the passes will be at the bottom, the fails come to the top. And then as we go over here to this next column, the minimum of specification, Sometimes there is no minimum or there is no maximum, but there'll always be one or the other. And then the value here in the middle, what we actually got when we ran that monitor, not what we're looking at now in the bay, not dynamic information, but historic information for when the monitor last ran. And being non-continuous, that could be yesterday, that could be last month. As we go to the next column, that's the max, and finally gives us our units of measurement, pressures, percentages, voltage, whatever. So as we look at this first one and we then click on it, it comes down here in this blue area and defines what we're talking about. Even in a non-color type of monitor, this monochrome OTC, for example, this EVO, it is also going to give you the ability to click enter when you scroll down and you get on one of those Mode 6 test IDs, and it will then blossom out and show you what it is you're looking at. In this case, we have evap system monitor, and what is the $00? What is specifically are we looking at for evap? And we're looking at phase 4 vapor generation. So these have failed, as well as this other evap test, $2B and $00, also evap. Here's one for EGR. But guess what? Is the customer complaining about EGR or evap? Do we have any codes for either of those? No. Customers complain about it running rough. And the light came on when it ran rough. So we're assuming a misfire. We're looking for misfires. So as the old saying goes, if it's not broke, just because it doesn't pass a test, doesn't mean it's broke. If it's not getting a complaint that's germane to what you're working on, you need to overlook a lot of information you'll see in Mode 6. This is part of the discernment that takes a little bit of training and a little bit of experience to wade through. Otherwise, it can be a bit frustrating. So remember, if it's not pertinent to your customer's complaint, just weed on past it, make notes of it, record it, so you may need it in the future to explain to your customer. They may have some additional services done later, or to explain these things existed before I fixed your misfire. I click on this last one that failed, and guess what? I've got a misfire monitor, $54. It's just saying it's bad enough for the cat to be damaged. In some point in time, we kept running this hard and we smelled the sulfur smell from a lot of unburned fuel going into that catalytic converter. We're pretty sure we'd probably damage this catalytic converter. So I'm sure the light would start flashing at some point in time and we'd finally set a code, hopefully. But how can we figure out right now which cylinder it is? If we had the Ford IDS, there's functions in here to tell you what's going on with which cylinder. In the case of other scanners, Mode 6 comes to the rescue. That's why it became familiar to a lot of you technicians when you began using Mode 6 is determine which of the early OBD II Fords was having the misfire, which cylinder it was. So as we scroll on down to the ones that passed, the ones that passed with flying colors in greens, the ones that were borderline in yellow, as we get on down to another 50 series in those PIDs, test IDs, and we get down to $53. We see cylinder number 1, TID01, component 01, I should say, SID01. That's the specific cylinder. Here we go, cylinder number 2, specific cylinder. They're all passing, but guess what? Here's one that budged the needle, if you will. So here on cylinder number 5, $53 is what's called cylinder-specific misfires on Ford pre-CAN bus vehicles. The 02 for the actual component ID, SID, is showing a little bit of action. It's halfway between the minimum, which would be 0 or nothing. You can't get better than no misfires, so there is no minimum. But the maximum is, let's say, 23%. So in the middle somewhere, we're not at the edge, we'd be in yellow. We're not over the limit, we say fail and be in red. We said pass, but we see something going on there. So that gives you an inkling of an idea what's going on with this engine. Are we missing a specific cylinder? I would say cylinder number 5, this left bank front hole, that's what I want to look at with my compression gauge, my scope and my meters, check out the coil unplug, check out the injector, and anything else that can come and go and cause an intermittent misfire. One important thing to remember when you're looking at Mode 6 data is that just when you think you've got it figured out, you work on a car and it's all laid out differently. Why is that? Well, For one reason, improvements have been made when it came time to have a new data bus. The engineers said, hey, we have a new serial data bus for modules to communicate with each other and with the scan tool. Let's clean up our act a little bit with Mode 6, make it a little bit more structured. And while we're at it, we're going to change the terms to upset technicians. I'm just kidding about that, but it has changed. So the CAN bus innovation, whether it be applied to a European car in the late 90s or an Asian or domestic car starting in about 2003 and 4, seeing more and more cars in 05, 06, and 07, and then by 08, they all had it. So you need to know if the car you're working on has CAN before you do much diagnosing and research in what we're going to see here coming up next, the websites of resources from your factory OEM internet information provider. So we're going to look at that, but we need to know if it's CAN or non-CAN. An easy way to tell, if it's an 08 or newer, it has the CAN data bus, control area network, and it will have in pins 6 and 14, I should say cavities 6 and 14, of the 16-pin J1962 standard OBD II connector, it will have terminals. Let's say it's an 04 Dodge Durango. Gee, I don't know off the top of my head if that has CAN, it's an early CAN user, or maybe it's an 05 Ford Fusion, and I don't know that one. Maybe you do. But the way to determine is just get down there under the dash with your little flashlight, take a look at the cavities in pins 6 and 14. If they're populated with terminals, both of them, you've got CAN. Now, there's an exception or two out there, some late 90s Chrysler and Dodge that used SCI buses that they stuck in one or both of those terminals. But for the most part, if it's mid-2000s and up, which would be a candidate for a possible Mode 6, and obviously 08 newer, it is automatically, and you want to know for certain, it's probably going to be 100% certain. If you see 6 and 8 populated, you got the CAN data bus. So now let's take that bit of information and go and talk about some of the resources out there on the internet. Some free, some a reasonable fee, and some of them also actually may be in your Mitchell and All Data and other aftermarket sources of information. Let's check it out in this clip for help when you need resources for Mode 6. Mode 6 data can sometimes, I won't lie to you, be a little hard to understand. Well, there's documentation with most all the OEMs out there you can just click on, some for a very minimal charge and some are absolutely no charge. Let's take Ford for example. I'm going to go to OEM One Stop, make that a favorite on your browser, OEM, the number one, the word stop.com. That's from NASTF.org, National Automotive Service Task Force. Very easy to use site. Click on whatever you're working on. Let's say I'm working on a Lincoln, and I'm going to have this pop up here. And I'm going to have the ability from the motorcraftservice.com site that it took me to from OEM One Stop when I clicked on Lincoln to a bunch of things that are free, non-subscription services, and then also my subscriptions. Subscriptions will be for the service manual, downloading calibrations to update a PCM, things like that. So what I'm going to do is I'm going to click on OBD II theory and operation. Remember that when you work on a Ford, Lincoln, or Mercury. OBD II theory and operation in non-subscription resources. It almost sounds like it's going to be too mundane. Watch what happens here. As I open that up and I scroll down to whatever model year from 2016 all the way back to the very first OBD II car, 1996, I'm going to click on what I worked on here earlier at 2001, and I'm going to be able to scroll down and find the different MIDs and TIDs or TIDs and SIDs, whichever the case may be, non-CAN or CAN bus vehicle. Now we have our 2001 Ford document up. We come down here, we can actually get it to print, or more practical, since some of these can be 200 and 300 pages, save it as a PDF to your hard drive or to a jump drive, whatever you want to do. Now, this is everything you wanted to know from A to Z about OBD II. Some of this is fairly basic, some of it's very, very advanced, and it will help you in some rare cases where you're getting a lot of frustration with a very tough to solve diagnostic problem with drivability. Now, instead of scrolling down through a bunch of pages, what we can do is go to Edit and Find, and remember what it was? It was $53 was our cylinder-specific misfires for this 01 pre-CAN Lincoln that had a shake when the engine was misfiring, and we had a code, but that code went away, but the light was on. So $53, go ahead and say next. And there's the J1979, the SAE standard for Mode 6 data. And these particular TIDs, test IDs, and their component IDs, specifically cylinder specific. Remember we had $50 and 00. That was just saying that we've got something that's going to possibly kill the catalytic converter. Don't know which cylinder, but when we looked at the $53s and looked at 00 through 0A and so forth, cylinders 1 through 8, we ran into a little bit of a number that did budge the needle, if you will. Now, what do we do with that number? Well, it's cylinder specific, obviously, and right there it says there's a conversion. There's a conversion number you multiply. It's 0.000015. So to get the exact percentage of what that cylinder is misfiring, we take the value we saw in Mode 6, we multiply it times the conversion number, and now we have a number we can look at and get our head around and go, oh, 18% misfire. That's pretty close to the 27% misfire that's maximum. I'm interested in that. If it was 0.18% misfire, I'm not too interested in that. That's a low rate of misfire. But in this case, we probably do have a bit of a problem. That's where you find that information in Ford. So what TID and MIDs mean and so forth. Now, for other vehicles, let's say General Motors, you do the same thing, the OEM1stop.com. And for example, I have a couple documents already up, one for Chrysler. Now, Chrysler will be a minimum charge. You have to actually log in to their website, and there's a minimum charge, but you can, for a very reasonable fee, pull up, and I've downloaded these all to my hard drive to save them for one fee. So here's all of the different TIDs and SIDs for Chrysler Mode 6. Now, it gives you a little bit of an update on what things mean and so forth, these different applications on different computers, JTEX and SBEX and whatnot. And then here again, there's the TIDs and SIDs. You notice there is no misfire TID, no misfire TID whatsoever, no test for misfire. The reason is, technically, misfires are a continuous monitor, not a non-continuous monitor. But a lot of OEMs, Ford, with both pre-CAN and post-CAN, have misfires in their Mode 6 data. Earlier Chrysler pre-CAN vehicles, like this 99 I pulled up from the Chrysler website and downloaded it, saved it, that does not have misfire diagnostics. It does not, it has it, it doesn't have it in Mode 6. But if we look at a newer Chrysler, here's one for an 08, and that does definitely have the Mode 6 information. Here's a Durango for misfires. We scroll down, we will see misfires on the list here, right about there. Here we go, misfire cylinder data 1. So it does change from pre-CAN to CAN on different manufacturers. General Motors has the same thing. You can download most of the stuff on Mode 6 definitions anytime you need to from OEM One Stop. Just go to the factory site from there, and the rest is just a little bit of research. Lots of resources out there, as we've seen, not just from the OEM sites, but also from the aftermarket sites. So make sure you take use of them and just don't look at Mode 6 on your scan tool and get frustrated. Now, things that can lead to frustrations. We're going to talk about the example here on this ease scan tool screen capture of a TID 25. Now, being TID and SID, TID for the general area, EVAP, and SID, component ID, for the specific area. It is spelled out here. It's vapor generation max pressure rise. So we're looking for a positive pressure. As you know, different EVAP systems work differently. Some use negative pressure to look for a leak and positive pressure, and some just see if the pressure rises because we've sealed it off and we have fuel warming up in the tank. Now, if we look at the actual value, it's a negative number well below the minimum specification of about 2.3 almost inches of water. The maximum specification, of course, being out of limits, just, you know, there is no maximum specification. So we need to be somewhere in there, and we have a negative, we have vacuum on this system, so that's no good. Now, typically, you'll have decent codes. Well, I shouldn't say that, right? Typically, you may have a P0440, and that just says, hey, you got an EVAP problem. Not sure if it's electrical, if it's a restriction in the vent, if we got a leak, to the atmosphere if we got a leaky purge. It just got an evap problem. That's all 440s really say. So if we looked at mode 6 and seen there were 4 or 5 CIDs within TID 25 that had to do with evap, then we could see which one of those elements, which one of those building blocks or sub-steps of the monitor, when it ran, did not work right. In this case, we didn't build up enough pressure. We had vacuum. So we look and see how the system works and see how that symptom that we've seen in this part of mode 6 applies. So there's where it can be super, super valuable. Now the things that can lead you to frustration though, in my first bullet point here, that fail, well, that's a good thing. That's pretty much says it's been flagged. However, sometimes they fail and there's nothing wrong. Let's say we take the case of we don't have an evap code, we don't have an evap complaint, the customer and you have kept an eye on that check engine light, and all that's ever happened to the vehicle is maybe a catalytic converter issue. So why would these things fail? That's a mystery. There's just variations sometimes where we do fail test, but software may prohibit the check engine light from turning on because the engineers have determined our test wasn't that great, so we're just going to mask out the check engine light. So we're not going to set the code, but we'll still run the monitor and show the fails. So as the old saying goes, as I said before in the clip, if it's not broke, don't fix it. However, if it is broke, we do have a 440 or evap-related code, then that fail column, we really need to study what's going on. But some of those frustrations, default numbers. Instead of a negative 63.896 like you see here on the screen, let's say we saw 2.297 exactly. And you think, whoa, what a coincidence. I just barely made it. And on some of the PC-based scanners that have it in color, it'd probably be in yellow, meaning you just barely slid in home base here, pal. That is not necessarily a reliable value. Typically, if you see the value that's exactly the same as the specification, it's a bogus value. It's a default because the monitor hasn't been ran or hasn't been ran since the last time the code's cleared or hasn't ran fully, whatever. And sometimes, believe it or not, the monitor will say it's ran, but it hasn't fully ran. You've got to clear the code and try to really run the monitor. Normally, if it says it's ran, it's ran. If it says it hasn't, but there are exceptions. Now, also there's improbable data. Improbable data is a number that is just like, wait a minute. The value here in units should be in time, in seconds, milliseconds, and I've got a negative number. Now, I've heard of negative pressure. You have too. We've heard of negative voltage. You get your clips on your voltmeter hooked up backwards. Never heard of negative time. There's no time machines here in mode 6. So you see something that just looks implausible, improbable. It probably is because it's the default value. It's non-existing. You see all zeros, same thing typically. So we have to take some mode 6 results with a grain of salt, a little bit of discernment like I talked about earlier. Now there's also, to add to the fun here, are the undocumented category. So we may know the general area, TID, test ID, or in CAN speak, as we'll see next on this late model Ford, we see it, the MID, monitor ID, but the specific area, test ID, they changed their terms around. The specific area, what we're looking at, in this case it says undocumented, but it's something to do with evap. You may have to go to your resources we just showed you on the little internet clips earlier and find that information. So clearing codes is the way you reset and get new mode 6 data, but you've got to run those monitors first in order to get past the zeros, the improbable numbers, or the default numbers like an exact spec and the values mimicking that. So those are things you got to make sure you do. Also, as I mentioned before, OEM enhanced powertrain is where you try to get mode 6 data first. Sometimes it doesn't always come up there, but if you can, go there. The reason is you will see a lot more chances of an undocumented TID, I should say CID, component ID, or in CAN bus vehicles, the test ID. You will see more chances of undocumented details of what it is about the evap we're checking in the OBD II generic than you will in enhanced. So that's the reason you want to go into enhanced whenever possible. And of course, clear the codes. You're going to reset mode 6 data. Always remember that. So if you're going to clear codes after you fix the car or made an attempt to make a repair, always make sure you've recorded mode 6 information prior to that, as well as the freeze frame and the DTCs itself. Now, let's go ahead and take a look at a newer car and see how those terminologies of TIDs and CIDs have shifted to MIDs and TIDs with this EVAP case study on this new Ford Fusion. Well, we've got a complaint with this 2015 Ford Fusion with a 2-liter EcoBoost that the customer says the check engine light comes on and off. It's on right now. We pulled the codes and we have a P0443. Now, this particular code says purge valve circuit fault. I want you to remember that before we go farther. Now, first thing we'll always do with anything is we're going to look at codes and then data parameters, or in this case for mode 6 topic today, we'll look at mode 6. So let's take a look at mode 6, keeping in mind what the code is. It is an EVAP code. So we should see some really good juicy information in mode 6 to share with you. So let's go ahead and go into mode 6, get back out to our powertrain full menu here. There we go. Extended onboard monitoring test results. We're an enhanced powertrain. Now we can also see mode 6 in generic powertrain, but we'll usually see the defined parameters, not always, but we'll usually, if we're going to find them, we'll find them in enhanced. So we're in mode 6 in enhanced powertrain. Go and see what the categories are. They're going to be a little different than what you've seen with pre-CAN bus vehicles. And here we go. The first column I'm going to highlight here, Monitor ID. That is a new name for the pre-CAN bus generation of vehicles that was called TID, Test ID. A monitor, a test, they're the same thing. Now, the next column is called Test ID, which gets confusing because that was the first column. Now it's the second column, but it means the same thing that the pre-CAN bus vehicles' second column also meant, and that would be the specific area of a test or monitor ID. So if I click on this to get the definition coming up here, down here in the blue, this particular monitor ID, the general area that we're checking here, is an O2 sensor monitor on bank 1, sensor 1. Now the next column, the specific aspect or component of that particular test, is $88, and that is defined undocumented. It means we have to go to Ford documentation, which we'll do later, to show you what that really means. So as I see yellow and it says the word pass, up here is our little key, passed with flying colors is green, barely passed, borderline yellow, and failed is red. Now the failed on a pretty much any scan tool, whether it's monochrome or it's got colors like the Ford IDS or the Delphi tool, whatever, you will have the fails show up first. And if they're not monochrome like that, if they're in color, they'll be in red. We have no reds. They'd be on top. Everything is saying pass, pass, pass. Variable valve timing, variable valve timing. There's an EVAP. We have an EVAP code, have a purge code, but it says it passed. Just barely, but it passed. This minimum column and the value, what we actually ran when the monitor ran. Remember, mode 6 is not dynamic live data. It's data that was recorded, like a snapshot on your scanner or a freeze frame when you have a code. It's the data captured when the monitor ran. Whether it passed, barely passed, or failed, it's the data captured when the monitor was ran. And we're all seeing all these barely passes. That was dead right to at the very edge between 8192, the minimum, and 1992, the maximum. This just barely had enough negative pascals pressure to pass. But it's turning the light on. How can it turn the light on and pass? As we scroll on down, we see a lot of misfire monitors and so forth. You notice they're not $ for misfires. They're not $53 like in pre-CAN bus Fords. It's $80, 81 and so forth. So as we see the $81 cylinder specific misfires that was so handy to have with pre-CAN bus misfire detection and diagnostics, but we're not seeing anything fail. Now we're down in the greens and we see everything looking good, including, here's another mid monitor ID and its aspect undocumented, $80 for the EVAP monitor for a 90 thousandths leak. Man, if that purge is not working correctly when you hook up your smoke machine, remember, When you're working on evap, smoke machines just find leaks. If you have a performance issue, plugged vent. If you have a leaky evap purge solenoid, it's letting vacuum on through when it's supposed to be shut it off, that's going to be a performance issue that the smoke machine may not necessarily catch or catch easily, especially the plugged up vent and so forth. And it certainly won't catch, you remember the code I asked you to take note of? The 443 evap solenoid circuit. That's not going to catch a circuit problem. Your meter and your scanner will catch circuit problems. So this is why we're seeing when we have a light on, an emissions related P0443 light, and that's evap related, and evap is one of our non-continuous tests that we always find in mode 6. Why we're not seeing the reds, we're not seeing failed mids and TIDs, because the test never ran that far. Once the computer woke up and says, whoa, we got a circuit problem, shorted or open on my evap solenoid. The computer says, why check for a plugged vent? Why check for a leaky hose when I've got a bad solenoid circuit? Solenoid itself's bad, the wiring's bad, the terminals are bad. We can fix that with a meter, like I said, and the scan tool or scope. You don't need to go further into mode 6, and that is very much worth discussing today, because sometimes we see things that look great and we just lose our confidence and say, well, man, that mode 6 didn't tell me anything. Yeah, it did. It's telling you that before the solenoid failed, we ran all those monitors and they were all good. A couple of them were close, but they were all good. So what do we do here? We would diagnose the circuit problem, the 443 electrical issue, not a leaky issue where we need a smoke machine, but the electrical issue, diagnose it, repair it, make notation of all this information in mode 6 that we see here, even especially the ones that were just barely passing, and then clear the codes, drive the vehicle, run those monitors again, and now see where everything lands. Well, as you can see, some things are straightforward and some things can be a little muddy. That's OBD II. That's just car repair in general today, isn't it? Now, one thing we want to really emphasize, record known good vehicle mode 6 values. Watch how monitors complete. Watch how the numbers go from improbable or to right on the specifications or zeros to some other numbers that you can get your head around that makes sense to you. So as we said before, clear the codes, make those monitors run again, do the drive cycles, and we know that it may be difficult, but also look to see which monitors don't run. So which ones ran quickly, which ones took longer, and the ones that never completed. And beware, they may say they've completed and not thoroughly completed. I've known that. I can't tell you why, but I have seen it. But when you see those numbers not really making sense, that's when you probably haven't ran the monitor fully. So try it again. Now, some things that can suspend monitors and you'll never see them fully complete and give you good mode 6 data would be problems in other areas that are related. For example, catalytic converter efficiency. Whether we set a 420 or 430 or not depends on a couple other components besides the catalytic converter itself. The O2 sensors, pre and post catalytic converter sensor, O2 sensors have to be performing well before the PCM will trust them enough to go ahead and run the CAT monitor. So the frustration you run into, you had a code for an O2 sensor or maybe a drivability problem with no code, but you found the O2 was just not too savvy. It was just a little lazy. You pulled it out, looks like it'd been in a chimney for a couple of years. You put a new one in, and you drive the car, monitors look complete, you didn't go to mode 6, there were no codes, no pending codes, boom, you put a stamp on it, call the customer, come and get it, they come back in 2 weeks. Guess what happened? With fresh O2 sensors, you now have catalytic converter monitor efficiency monitors run, and it may run 2-3 times, be borderline, and then 2 weeks from now, it finally ran and it failed and turned the light on. It failed twice, turned the light on. How could you have prevented that comeback? Well, it's hard to tell the customer, well, the check engine light's on for a different reason, sir, and that'll be another $500 or $1,000. It's easier to tell them, we have fixed one problem, another problem may be brewing. We're going to hope and pray it doesn't happen, but we're here to help you if it does. The light comes back on and you knew it was going to. Or maybe you just sold them a catalytic converter on the spot. Run the monitors and look for values that go from improbable, right at spec, or zeros to numbers that are right in the middle and get you the green, or at the yellow, meaning it's getting ready to fail. That's when it's time to start talking cats to the customer. Some other things you want to ask yourself every time when you go open up your scanner, your laptop, whatever, looking at mode 6, you ask these 4 questions. Which monitor failed? Which TID is saying failed? Or MID if it's a CAN bus vehicle. What component, what CID or TID in CAN speak, failed? What's the test limit and what's my actual value? Looking for the bad information, the stuff that's failing in mode 6, if it's not in a system related to your customer's problem. That is very important. Mode 6 data is only available if you have a mill-related problem. So if it's a DTC that won't turn on, check engine light. You're not going to see mode 6 on it. If it's not powertrain at all, you certainly won't see mode 6. So obviously mode 6 does not apply to chassis and body, as much as that would be cool if it did. Also, you can use mode 6 to verify the repairs, but how you do that's going to vary. Like I mentioned the example of the catalytic converter efficiency. You can verify if the cat's working, if you do replace a cat, by running the monitors and seeing where that falls into the minimum maximum specifications. Now, also keep in mind, and I understand your pain on this, I do a lot of classes in big cities, and the techs look at me and go, yeah, run the monitors right. In this neighborhood, I got to drive a half hour to get an open road. Or in like New York City, it may be 2 hours to get a good open road. Well, you may, if you want to be top notch using things like lab scopes in mode 6, a high-end drivability, you want to be the best shop in your area, may look into investing in a dynamometer, because you may have to get that vehicle somehow rolling to get the monitors. There are tricks you can do sometimes to force monitors to run, but for the most part, you really got to drive it one way or another. So now it's time to test your knowledge, and then we'll give you some time. You can test my knowledge some more and ask me some questions. So let's go ahead and get started right now with our first question to you. What reasons are there, number 1 here, to view mode 6 data? When would you want to go in and use this mode 6 data? A, to determine which cylinder is misfiring. B, to find the cause of a P0440. C, to prevent P0420 comebacks, or D, all the above?
All right, Dave, all our answers are in, and we've got 18% saying A, 9% saying B, 9% saying C, and 64% saying D.
The 64 percenters have it right. It is all the above. You certainly can use mode 6 for all these things. You wouldn't want to use mode 6 if it was just basically a low-hanging fruit type of an OBD II problem. You've got a code for a bad mass airflow. There's no signal out of it. You put a new one. It looks dirty. You put a new one on. You're good to go. You would never use these advanced tools, just like you don't use certain tools in your toolbox that are a pain to use when you can use what's on your tool cart. But definitely, cylinder misfires, if it's a Ford and it's not spelled out in data parameters, does not give you, like in a Tech 2, a bar graph of how bad which cylinder is missing and so forth. The 440 is so ambiguous that's like, well, you have that problem, give me some more information. Definitely mode 6 is a must there. 420 comebacks we talked about with the CAT efficiency, looking to see how close we are, and hopefully we didn't miss the mark on that. So all the above is the correct answer. Now here's our next question. Most factory scan tools can display mode 6 diagnostics. Should be an easy one. Select your true or false answer now.
All right, Dave. All our answers are in. We've got 85% saying true and a lonely 15% saying false.
How interesting. This may be a cup half full or cup half empty kind of answer. I'm saying false, all right? But if you said true, we can agree to disagree, or I might even be swayed to your way of thinking if we're on the same line of thought. If you look at DRB3, Chrysler factory tool, traditional, for the independent aftermarket, yeah, some of you are getting the YTECs, and some of you are getting, IDSs and so forth, but DRB3, Tech 1, Tech 2, DRB 2. I believe some of the other scanners out there, NGS and so forth, some of the Asian scanners did not do mode 6 originally. When they became PC-based scanners, for the most part, is when we started seeing the factory tools adopt what the aftermarket tools have always had, and that is the option to go into mode 6 diagnostics on OBD II. So traditionally, the answer would be false, looking at the older scanners, but if you're looking at IDS, you're looking at TechStream, available on any reflash tool, or you're looking at even the new MDI for GM, replacement for the Tech 2, they do it, so I can see how we'd have a bit of a controversy and maybe even reverse a scenario. All right, next question. What happens when a DTC is erased? A, non-continuous monitors are reset to incomplete. B, mode 6 data is erased. C, freeze frame data is lost. Or D, all the above.
All right, all our numbers are in. Wow, you should be happy. We've got 5% saying C and 95% saying D.
Well, 95%'s gotta be right. How can that be wrong? Definitely non-continuous monitors are reset to incomplete, although when you're driving, some of those monitors will pop pretty quick. Some will seem to take forever. And mode 6 data is erased now, not really erased like blanks, but what you'll see is, in some cases, you'll see some of the TIDs and SIDs at the very top will have bogus numbers, zeros, borderline right on the spec. And on the bottom, you'll see a bunch of incomplete. So it'll be kind of all over the board what it looks like on your scanner. But man, when you start seeing decent, believable numbers pop up and the incompletes go away in mode 6, and of course in your readiness page on your scan tool, what gives you the monitor statuses, when they start saying complete, complete, then that definitely is when they finally have recorded the mode 6 information at that particular point in time. So freeze frame data is lost, as we well know. It always asks you, are you sure you want to do this? Because you're going to lose your code and your freeze frame. So that's as well. So the answer is D, as in Delphi. Next question here. Mode 6 data is continuously updated while driving. True or false?
All right, Dave, our numbers are in again, and we are looking at 43% saying true, and 57% saying false.
Very, very good. I wanted that. That's a deliberate question that has both true and false. I went ahead and circled false, I should say. If you circled true, that's fine too, because this is the whole gist of it, and I really wanted to make this a typical mode 6 question, because mode 6 is not typical. The question is mode 6 data updated continuously while driving? Well, technically, mode 6 is a study, snapshots in history of the non-continuous monitor. So a monitor that only updates once or twice per drive cycle. So you get in the car, you do a 40-degree sweep up in temperature, you do your speed up, your idles, the whole thing to get you the drive cycle, hopefully. And those batch of monitors all run, but they just run at that point in time. So technically, the answer would be false in that regard. They're not constantly updating evap, boom, 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 every mile or two down the road, for example. However, misfires are in mode 6 in GM and Ford and others, and new Chryslers, but not older Chryslers. So depending on if misfires are in the mix of mode 6 or not, misfires are updated more continuously, and they will update mode 6 information. Let's go to, I believe this may be our last one here. Tech A says, improbable mode 6 data shouldn't be trusted. Tech B says, if data is in zeros or at specs, don't trust it. Who is correct? Tech A, Tech B, both techs or neither tech? Select your answer now.
All right, Dave, our answers are in. We've got 20% saying Tech A only. We've got 55% saying both, and then the remainder of the 25 say neither.
All right, well, that 55, you've got it, is both technicians. Now, improbable data, it's like through the roof crazy numbers. If it's at zeros or it's exactly at specs, can't trust it either. It probably hasn't ran, or it's either not warm enough, something's causing it to suspend like some other test that failed, so we're not going to run this next monitor, that sort of thing. But either way, we can't trust the data. So that's part of the frustration, but that's part of the challenge of fixing today's tough drivability connections and diagnostics and so forth, because it is a very deep subject. We're still learning. Mode 6 is a learning curve for all of us, like scope patterns and anything else that's high end. I want to thank you for watching. Now let's go ahead and turn over the questions to you and see what you've got out there. And I think, Christian, you've got some already in the hopper from people who've been writing their questions all along here.
That is correct, sir. We've got a question here that relates directly to what you're just talking about, and what he would like to know is, how do you confirm that a value given on a monitor is default or made up?
Okay, well, if it's a mode 6 value, as we've mentioned, and you well know by now, at least anyways you do, the value is not dynamic. It's not happening now. It was something like a failure record, freeze frame, that happened in the past when a monitor ran and passed or failed. If that is what you are not sure, is this a default number, the bogus number that made up, just something that engineers just slide in there to take up space before we get the real number when it pops up, when and if ever it does, this is what I would do. Obviously, the improbable we talked about, crazy numbers, no way it could happen. Zeros, it's just not going to be accurate usually. And then right at exactly at the spec, also very improbable. So I just throw those out. But if it's a number that's maybe doable and you're not sure, then go ahead and clear codes and run the drive cycle and see if you get the exact same number again. What's the chances of all the variations? If you see an engine idling super smooth, but you see RPMs doing this, that's normal, we know that, right? What's the chance of hitting that exact same threshold again? Pretty low in my opinion, so that's what I would do. Now, if you're talking about live data on the scanner, RPMs, fuel trim, things like that, then what you want to do, if you're in OBD II generic, that's as accurate as you're going to get. Doesn't adhere to this requirement, kind of not so etched in stone SAE requirement that says if you're going to do a default live data PID change, in other words, let's say somebody unplugs the coolant temp sensor and it's open. Normally in the old days we'd see -40. If it was shorted, we'd see 300 or something like that. On enhanced OBD II data, live data, like we usually do with our scanners, we go to enhanced, you'll see today, more than ever, a made up number, and it's believable. It's not a zero, it's not exactly at some spec like -40 or 300, the very edge. It says 150, and by golly, my intake air temperature says about that too. Well, that's where it's getting that information, from another sensor. It's plugging that default value in. Where would you find the real McCoy number? You'll find it in OBD II generic. So it's always good to go into global. Mode 6, I prefer enhanced powertrain. But on other things, I go to global a lot. CAN bus vehicles, you're seeing dozens of PIDs instead of a handful of PIDs in global. And the PIDs will be the real McCoy numbers, not the fail-soft made-up default numbers.
Got you. Thank you, Dave, for that answer. I've got a very specific question here that hopefully you'll be able to answer. Can you tell me if an OTC Pegasus can work on a 2001 Mercedes ML430 from Germany? Because MotoLogic does not have this year, because I have a DTC code P1177, P1178, and P1179, and P0161 Bank 2.
I've got a friend that I think may have that answer, and I'm going to ask him as soon as I can, get an email off to this gentleman, because he works for a company, is involved with this, and he's an expert on this particular scanner. I'm a little bit more of an expert on this one, obviously, with our name on it, but we'll try to get that answer for you. That's an awesome question because it's what any instructor or engineer would want as the details. But that it's interesting. Now, is that Mercedes for Germany, or is it a import like any other Mercedes you buy at a dealer here in North America? If that's the case, I need that information as well. So have him instant message you. We'll get you an answer on the Delphi website.
I got a question here. It says, how long does it take to run monitors?
Well, it's going to depend on the type of monitor we're looking at. Depending on driving styles and habits of the customer, it can take days, even weeks. I've even driven across the state of Texas in several different OEMs with either the gas cap off or on the capless cars, a little Allen wrench shoved down to open up not just the first little flapper, but the second seal that really seals it, and never set a light. And I ran through several tanks of gas, stopped for several nights and so forth in my training tours. So it can be frustrating getting monitors to run, and others will just like, man, I'm just trying to clear this code and do some work and the monitor pops right away. So it's all over the place, truthfully. What you want to do is look to see what the monitor requirements are. So the enabling criteria for codes, for example, well, there's an area enabling criteria for monitors. I know on our tool, we have actually a page in one of the OBD II enhanced powertrain menus where you click on monitor requirements, and it actually gives you by monitor all the different things you got to do. There may be some monitors that are simple, get up over this speed, over this temperature for 30 seconds, and other monitors are more like a complete drive cycle to run all the monitors where you're doing different speeds, different temperatures over the course of, let's say, a couple of different occurrences. So that's going to vary very much. It's really a difficult question to answer simply.
Got you. Thank you, Dave, for that answer also. I've got a comment here that says, most older OEM tools didn't support OBD II. I'm imagining he's referring to global OBD II.
That's a very good comment. That's so true. And I remember seeing, this is kind of crazy, I remember seeing an option. I'm not sure if it was the old 10 meg card or the bigger card, PCMCIA card in the Tech 2. But there was an option for global years ago, the Tech 2. It disappeared, I believe. I know with the Toyota Tech Stream that I could run on any PC using a J2534 as the backbone, the pass-through. I was seeing a global OBD II where I could scan a Buick with the Toyota tool. It did a pretty decent job, and I loved the Mode 6. It disappeared. And I actually talked to the folks at Toyota Hotline, and they said, well, they had some issues with it, so it may come back. And I don't remember, Christian, quite frankly, if it came back or if it came back and left again or what the status is now, but it is something that the factory tools have played with here and there. But traditionally, that's correct, especially the old guard. Some of the old hold it in your hand, NGS, Tech 1, Tech 2, definitely, they didn't need to because they had enhanced, and they figured that was all they needed for that particular make and model of car. They're not going to worry about Fords when working on a GM or vice versa. Got you.
There's a comment that just came in that says, OTC does that also, tells you how to run monitors.
Yes, yeah, OTC, that's great. I'm seeing more and more scanners do this. This is a good feature that you want to see if your scanner has and utilize it. Because there's nothing worse than going, well, let me see. I've got a drive cycle book that tells me how to do all the 8-9 minutes of whatever of all the different speeds and acceleration, deceleration, foot off the brake, foot on the brake, all this kind of stuff. But wouldn't it be nice if the monitor was a more simple set of criteria to enable it, to make it run, if we just knew that? So if you've got that on your scanner, use it. You'll really get a big kick out of it.
Gotcha. We've got two little questions that came in that are pretty much on the same thing, referring to Mode 6 capabilities. If the newest factory tools are used, do they do it? Mode 6. And another one that says, isn't Mode 6 available on generic scanners as well as factory?
Yes. Newer factory scanners, as we've mentioned before, are starting to see it. However, just because it's Mode 6 on, let's say, the IDS is no sign you're going to hook it up on your Hyundai or your Chevy in the bay and run it there. It's going to be mode 6 for Ford. And the same thing with a Toyota and so forth. Now, as far as the generic scan tools, I don't consider these two, for example, to be generic. These are technically called OE level. True dealer or true OE dealer factory scanner, like an IDS or a Tech 2 or something like that, that's one level. One level down from there is OE level. Not exact OE, but OE level, near OE, I should say. And then generic, like I think in the OTC line there was a small, I can't remember the name of it, but it was a much smaller package scan tool, and even down to the code readers that you can buy at your auto supply source, those that just give you a quick, OBD II code, generic ones that may have some OE specific codes. It just says undocumented. You got to look it up. But it pulls the codes. Most of them will also do mode 6. So from the generic lowly code reader up to the biggest, most expensive aftermarket OE level tool that there is, they all do mode 6. The question's always, does that factory tool you have do mode 6? And for the most part, older ones don't, newer ones do.
All right, we have a very good question just came in, and it said, is there any mode 6 type system on diesel systems? If not, why not?
Actually, there is. That's a very good question. I'm glad you brought that up. It's not as much stuff as I've seen in gas engines, because you just don't have like the fuel control O2 sensors. You may have something like an O2 sensor if you have an enhanced exhaust system, the selective catalyst reduction and that sort of stuff on the 2010 and newer clean diesels. But for the most part, you will see some TIDs and SIDs, or MIDs and TIDs if it's a CAN bus diesel, EGR flow and some things like that. They will be in the midst. So mode 6 does exist for the diesel technician, yes.
Got you. Just to let you know, we did get more information on that car from Germany, so that you can send that email out. So
great.
Very detailed. Thank you, sir, for sending that to us. We've got a question here. Can generic give us a bogus spec, or is it a true spec like its PIDs? That's what it says.
The mode 6 data that you read, as far as I know, the mode 6 data that you would read, let's say on a very min function scanner, or down to the code reader level, will be the same as far as legitimacy, accuracy, as what you would see on the bigger brothers. There shouldn't be any difference. The difference you get into is when you step up and you address mode 6 with these OE level tools, or of course the factory tool like the IDS, you go into enhanced powertrain in this tool or that tool. Or you'll be in enhanced powertrain pretty much from the get-go when you go into a factory tool. When you're in enhanced, those TIDs and SIDs will be the SIDs, the second column, which is the specific part of the monitor that's ran. We're talking evap, but what part of evap? We're talking pressure generation. We're talking about purge performance. That's the component ID, or in CAN terminology would be the test ID. That information should be, if at all possible, documented. And if you do fleet work in your garage, you've got a small fleet, you're taking care of, you may see some 15, 16 models in your bay. You're an independent aftermarket shop. You don't do warranty work, you're not a dealer, but you're working on them anyways. And so you have to lie to your scanner, tell a little fib and say, hey, it's a 14, because that's as late as my scanner goes, for example. And that's when we have issues with maybe this PID is not reliable, not germane to what we're talking about. It exists, but it's not working. And the same thing would apply to the mode 6 data. So I've seen on different scanners that are not true OE factory tools, and occasionally on them too, but mainly on the aftermarket scan tools, I've seen glow plug PIDs on a gas engine. Scratching my head going, nah, it's not there. So this stuff happens, and it can happen from the lowest little generic scanner up to the biggest one. The bigger ones, usually they got more budget and they fix those software holes, and the bigger holes get filled pretty quick because the people that own these tools call in and report it, and the engineers fix them with the latest update. That's one thing I like about our tool, is that the updates are done very, very often, and they sometimes are custom updates, and they'll update your little glitch a lot quicker than the whole, like adding a model year type of update. But anyways, yeah, they find the holes in coverage, they find the holes in accuracy, the holes in doing bidirectional communication functions, and little relearn configuration type things, and they fix them. And then sometimes I've seen tools go for a while and they never get something fixed. Nobody ever complained and told the scan tool people there's a problem.
Got you. Thank you, Dave, for that answer. We've got a small question here. It says, did you say when a rig comes in to do mode 6 first before scanning for codes?
No. Always scan for codes. Always verify customer complaint first, number one. Scan codes second if it's an electrical problem. I mean, the customer's complaining about a wobbling wheel. Obviously, you're going to set a rack and look at the chassis and steering suspension. But if you got an electrical issue, you got some kind of drivability problem, you got a warning light on, ABS even, go ahead and pull codes after verifying customer complaint. Pull the codes next. Then do visual inspection. Look for the goofy stuff. Somebody's added an aftermarket doohickey under the hood. Sensors fell off. Come unplugged. You set the rack. You see a wheel speed sensor hanging loose. Those kind of things. Look for the low-hanging fruit of something that's abnormal, broke, missing, whatever, burnt, and then go into data parameters and look at live data. Try to see if you can simulate, or I should say replicate the problem. And mode 6 is on down the line from there.
We've got one last question here, and it says, Dave, back to Fred Kicks the Can. New law that cars have to have 5 CAN systems now, question mark. I noticed that 5-volt engine sensors are called a CAN now. I think I saw. Can we clear that up at all?
Yeah. Whoa, that's a good one. Fred Kicks the Can. That was an update I did on CAN data buses. Now the 5 different, Christian, am I getting this right? 5 different CAN?
That's what he said. Question mark. New law that cars have to have 5 CAN systems now?
Not heard that. Now, I'm not sure about a law. I do know that I'm seeing, now federal motor vehicle safety standards have changed a lot since the last time I looked at those documents, and it's pretty hard to read. It's a typical legal document. But FMVSS may or may not apply to this, but I've seen this as an observation, more 5-volt power supplies. Instead of one, and you short, let's say, one 5-volt sensor, we'll say a AC pressure transducer on the high side of the AC line. That shorts out, maybe the wire pinches or the sensor shorts internally, and now the whole 5-volt system is down. You don't have TPS working, map, baro, nothing. That pretty much has been fixed with multiple 5-volt regulators, 5-volt power supplies coming out and feeding different circuits that are all hooked together. So unlike the Christmas tree lights, when you have a short and all the lights go out, this is like a bunch of different strings of Christmas lights. That I know about. As far as 5 different CAN buses, I'm not sure we got the question correct, at least in my head, but I'm aware that they may have expansion buses, and that's in that training program, Fred Kicks the Can. Expansion buses for chassis, because there are too many riders on the bus, even with CAN, and also expansion buses now for powertrain. We're seeing that. So it's like not just pins 6 and 14. It could be 2 or 3 or 4 other pins. And then, Christian, you've got the low-speed CAN buses. And then the buses that aren't even CAN, the local interface networks, LIN buses, and others that are just proprietary. They don't hook up to the DLC. Your scanner doesn't see what's going on, but they connect in with a bigger module, let's say a door module on a local bus, like a LIN bus connecting to a BCM. And then that's what you see on a low-speed CAN bus with your scan tool. Or if it's in a Chrysler, you may see the low-speed bus talk to a module on the high-speed bus called a TIPM, totally integrated power module under the hood, and that is your gateway to talk through a dedicated bus. Mercedes does the same thing through pins 6 and 14 to the DLC, called Diagnostic CAN C.
Thank you, sir. We got one last comment snuck in here at last minute, and it says, Thank you so much for showing what could only be called a God-given gift, because what you are doing for me on Moto Skill. Wow, after 2 years of UTI, I learned in 2 weeks with how you teach hands-on. Okay, now what I ask is what I would get first. He's asking what tools he should get first.
Okay.
You know, a vacuum gauge, power probe. He really doesn't know what he should start out with. So what are the 5 best diagnostic tools to start out with then?
I would get whatever your budget allows for a voltmeter, ohm meter, ammeter, a DVOM, digital multimeter first. That is going to be the biggest thing you're going to use the most often, and arm yourself with knowledge and training to use it to its highest level. And beyond that, I would build my way up from a collection. And of course, you know, I'm going to be partial to this one, all right, because it's got our name on it. But seriously, it's a good tool, but there's a lot of good scanners out there. I would never have just one scanner in my shop. I would have a collection of scanners I prefer that are OE level, that work on a lot of different cars. And for cars I see a lot of, if I have a ton of Ford customers, I'm going to have an IDS. I have a ton of GM customers, I'm going to have a Tech 2, or maybe even a GDI or MDI, which is able with the right software subscription to do Tech 2 emulation, so you don't need it for the older cars. The MDI does the newer GM and the older. So as the business case provided for your particular situation, add tools as you go. Beyond that, definitely electrically, a breakout box for the DLC. Boy, we could go crazy on a tool truck, couldn't we, Christian? But yeah, email me privately when I got a chance to really think about it, and we will get his email address. I'll email him. How's that?
Thank you, Dave, for all your time. Folks, that is all the time we have for tonight. I would thank you all for tuning in to this final live webinar in Delphi's live training series powered by AVI. If you missed any of the previous broadcasts, you can find them on Delphi Auto Parts YouTube channel. Be sure, though, to follow Delphi Auto Parts on Facebook and Twitter for regular updates from Delphi. Thank you, and have a good night.